Yeah. Um, Good morning, all. My name is Saurabh. So, welcome to the webinar series of January month. Okay. So we have a series of webinar of like 6 webinars. Okay. So this is the first webinar, which is on um, circuit design of hydraulics. Okay. And this is the agenda of today's webinar. So we are going to look at like electro-hydraulic circuit design with the help of like PLC control, manufacturer's catalog. Then again, we will see the hydraulic circuit using illustrated components like sectional component. Then the virtual trainer kit. We are going to take an overview of technical training material, that is a teachware, and then demo files. Okay, and then we can take the Q&A. Okay. So if you have any question, so you can pose the question in the question pane. We can address the questions in between. Okay. So before moving to the software, I would like to talk about our company. So we are a team of 150 engineers and software specialists. We are ISO certified company and we were founded in 1986. We are leading the industry by designing world-class trade-oriented tools in the fields of fluid power, electrical engineering, industrial automation, and custom software development. So we have 3 branches. Our headquarters is at Montreal, Canada. Then one office is in Mannheim, Germany. Other is in Pune, India. Okay. Okay, so we have in-house expertise in the field of software engineering and then industrial automation. We have software specialists working on software engineering, database design and support, network support, multimedia applications. We also provide engineering support. Then we also work on pneumatic systems, hydraulics, mathematical modeling, electrical systems, automation engineering, robotics, manifolds. Then we also work in PLC programming, SCADA, then HMI, electrical controls, process simulation, system maintenance, and robotics. So these are our products. We have Automation Studio Professional Edition to create, analyze, troubleshoot, and validate multi-technology circuit. This edition is specifically for industrial use. And then we have Automation Studio Education Edition to train future technicians and engineers on hydraulic, pneumatic, electrical, robotics, process control, and PLC systems to simulation. And this is the edition which is specifically used for technical institutes like engineering colleges, vocational colleges, polytechnic colleges. Then we have Automation Studio Live Manifold, which is a complete hydraulic manifold software solution for design, coating, and prototyping. And then we have Andon Studio, which is a complete solution to optimize the production, or you can say this is more related to Industry 4.0. So these are our objectives. We believe in long-term relationship. We have effective support by phone, email, or online. We have a dedicated representative for each account, and we also provide support material like training videos, demonstration files, quick start guides, etc. So these are some of our milestones. As we started in 1986, we were then known as Hydrosim and Neosim. In 1996, we started with Windows-based version, that was Automation Studio 1.0. From then till now, as per the customer's feedback and their requirement, we are progressing ourselves. Okay, and currently we are working on Automation Studio 9.0. So what is exactly Automation Studio software? So Automation Studio is a multi-user collaboration sharing software which deals in simulation animation, trade-oriented system design, and machine documentation. So you can draw your circuit on hydraulics, pneumatics, then some part of mechanical, then electrical control, electrotechnical one line. We have a separate library for digital electronics, instrumentation, process control, robotics. Uh, then you can draw circuits on PLCs, different PLCs. Block diagram. You can also link your Automation Studio circuit with the trainer kit using Canvas or OPC client. You can build circuit using SFC. Then there are some extraordinary features like Workflow Manager, FMEA, Teachware, Manufacturer's Catalog, Bill of Material and Reports, component sizing, energy consumption, and it fits for multiple programs as you can see here. So what are the key benefits of Automation Studio as per the students, teachers and school? For student, it validates theory studied in class. So whatever you are studying in the class, in the theory part, so you can validate that theory in Automation Studio. You can draw those circuits and you can just simulate them and analyze those circuit dynamically in full color. Okay. And for teachers, it facilitates demonstration of system interaction, enhance teaching and learning by working on virtual systems. Okay, no need to purchase a single technology software. As it is a multi-technology software, you can use this software in conjunction with other departments also. Uh, you can also provide like e-learning or remote access for students, and you can monitor them with the help of license manager. For example, if you want to give any homework or like project works to students, you can provide it to them at home and you can monitor them with the help of license manager. We have an international presence. We are available in 13 languages and we have sold our software in more than 150 countries. So our software is used in high school, career centers, colleges, universities, workforce development. So we also provide technical publications in Automation Studio. For example, you can see this circuit. This circuit is from this book, that is Fluid Power with Applications by Anthony Esposito. Similarly, there are many other circuits which are available from different publications. Okay, so you have to just go to technical training material tab, click on the exercise which you want to learn. Okay, you can also create interactive exercises in this way. Again, there are some built-in interactive exercises available in Automation Studio which are easily customizable and you can create your own exercise. You can also link um, trainer kit with the Automation Studio. You can see the circuit here in the Automation Studio. This is the same circuit which is available on this trainer kit. Okay, we have drawn in Automation Studio and we have linked this like Automation Studio to this trainer kit using OPC server client. So with the help of this OPC, you will get the real-time feedback of your trainer kit. You will also get illustrated libraries in Automation Studio. So we have libraries of PLCs, hydraulics, pneumatics, ACDC motor control, then aeronautics, sectional components. Okay. So you can see this is the three ways to create, simulate, and troubleshoot. So in Automation Studio, you can draw the circuit using ISO symbols, illustrate components, and then virtual trainer kit. So this is like you can see the video. So here you will see the pneumatic trainer kit, the actual trainer kit which you are using in your um, college lab. And here you can see the virtual trainer kit which is created in Automation Studio. So these are the same components. You can see these are the same components. So we have designed it in Automation Studio. Okay. Yeah. Then what is the benefits of virtual plus hands-on experience? If you're only using hardware kit, then only like 2 students per unit can work on that, right? And it will be an expensive option. But if you're using hydraulic kits plus Automation Studio licenses, there are multiple benefits as you can see here, and it will be really an like affordable option. One of the most important feature of Automation Studio is the manufacturer's catalog. Um, like we have ready to simulate pre-configured manufacturer specific products available in Automation Studio. So student has to just go to any of uh, manufacturer's catalog, click on the product which he or she wants to work, okay, and they can just drag and drop that component in that workspace, right? So in this way, the manufacturer's catalog will look. Okay. So I will show you more during the demonstration, during the webinar. So this is the partial list of our industrial clients. We have clients like NASA, Boeing, John Deere, Kubota, Caterpillar, Hitachi, L&T, JCB Defense, US Steel, China Steel, Epiroc, Komatsu, Honda, Skyjack, Terex. Okay. Yeah, so let's move to the software part. Okay, so I hope my screen is visible, the software is visible to all. So if you have any question, please put the questions in the question pane. Yeah, so this is the interface of Automation Studio Educational Edition 9.0. Okay, so this is the welcome screen. Okay, if anybody is using Automation Studio, they will be able to see the welcome screen. When you open the software, you will get the welcome screen, and here you will find different folders as per the technology like electrical, PLC, robotics, hydraulic. Okay, for example, I am clicking on hydraulics, so you will able to see the virtual trainer kits, the symbols, the templates you will able to see. If you are not able to get it, like which to use, you can directly click on default and start using the Automation Studio. It is very easy. Okay, so here on the left hand side you will find the library explorer where you will find all the technologies right from hydraulic, proportional hydraulic, pneumatic, proportional pneumatic, drive and transmission element, environment and control, instrumentation and process control diagram, electrical control, JIC and IC standard. We have a separate library for digital electronics ladder diagram. You can see like Allen Bradley, IC standard, Siemens, LS Electric, Mitsubishi. Then electrotechnical IC and NEMA standard. Then electrotechnical one line blocks, HMI and control panel, and then robotics. Okay, so this is the generic library. This is not the manufacturer specific library. Generic in the sense like you can configure the product as per your requirement and you can use it in your schematic. Manufacturer specific products will have the manufacturer specific behavior and the specifications, okay, which will be available in manufacturer's catalog. I will show you later, right? So starting with the like generic library, here you can see the arrow, okay, besides each and every technology. So here you will find all the components associated with that technology. You can see right from pumps and amplifier, intensifiers, then accum actuators, accumulators, then flow valves, pressure valves. Okay, you can find all the components here, right? Then on the right hand side is the project explorer. So whichever the project you are working on, you will find here. The top bar is the ribbon bar where you will find home tab, edit tab, view, simulation, system analysis, fluid, tools, student tab. So students can use the student tab. It is like very easy to use. We have compiled all the features from different tabs in the student tab. Okay, and then we have support and then technical training material tab. Okay, so so I will start building one hydraulic circuit. Okay, so basic hydraulic circuit I will build first, and then I will build one proportional circuit also. Okay, yeah. So here I will take one unidirectional pump fit shaft. So you can just drag and drop the component. I will take a reservoir here. Okay, so maybe I will take in this way. Yeah. Okay, I will take a double acting cylinder here. Okay, then I will take 4x3 electrically controlled valve. You can call it a DCV. Okay. So we will make some space here. Okay, then I will take a variable relief valve. Okay, and then I will zoom all the components here, right, in this way, and I will connect this circuit. So here you can see we have to just connect these Z ports, and the lines which you are seeing are not just the CAD line, they are actual pipes and hoses, and they are having their own properties. I will take one more reservoir here. You can take the copy of the product also. Okay. If you want to create any junction, you have to just double click on this line. And I will click here, right? So in order to drive this hydraulic circuit, I need either an engine or a motor. So I will go to drive and transmission elements and I will click on electric motor here. Okay. So this is my basic hydraulic circuit ready. So I will go to simulation tab and I will click on normal simulation. So you can just like see the simulation. So here the fluid is passing from this reservoir to this pump, then to variable relief valve, and again to this reservoir. So here you can see the different color in the line. Different color in the line means different pressure in the line. So here red color means high pressure and blue color is like okay, low pressure. So when I just click on this spool, you can see the cylinder will extend and the color will also change. Okay, you can see. Okay. So during the simulation, you can also measure the properties across this circuit. Like you can, so in the simulation tab, we have different dynamic measuring instrument. Like we have component dynamic measuring instrument. So if you want to measure any property across any component, for example, I'm clicking on this cylinder and I will drag and drop this measuring instrument here. Okay, then you can see all the properties related to a cylinder. Okay, here. So for example, I will choose the linear speed here. You can check the unit precision level. Okay, click here. Okay, if you want to measure the flow of this pipe, you can just okay. Then we have no dynamic measuring instrument. If you want to measure the like any parameter at any particular node, for example, I'm clicking on this node, so you can measure the density, pressure, temperature, viscosity. Okay, likewise, you can measure any other property at any node. Then we have differential dynamic measuring instrument. If you want to measure the differential pressure at any 2 point, for example, I'm taking these two nodes. Okay, so when you just click on this, you can see how these dynamic measuring instruments are working. Okay, so during the simulation, you can also change some properties on the components. Like you can give the external load at some inclination. You can change the cracking pressure of this variable relief valve. You can change the displacement of this pump. Then setting speed of the motor. Okay, so that is also possible. Okay. Now, like you can see, we are measuring the like some properties like pressure, then speed, but how to like represent, if you want to present it. Okay, so how to present that values? So here, like we can draw the graphs also. Okay, so we have different types of plotter. We have y of t plotter, then y of x plotter, and then set of xy plotter. So for example, if I want to take y of t plotter, so you can just click on this, and here you can just drag and drop that component. Okay, you can choose the property. For example, I'm choosing linear position. So scale will be generated automatically with respect to time. You can see. You can again drag and drop this measuring instrument. This measuring instrument was measuring pressure at this particular node. So you can just drag and drop. Okay. And when you start the simulation, you can observe. Okay. You can check. Okay. So you can see in this way, like the graph will be generated. Okay. It will plotted. So here in the plotter, you can adjust the scale. Okay. You can add the cursor here. When you add the cursor, you will get the value at that particular point. Okay. You can add multiple cursors. Okay. You will also get the differential value. You can add the annotation if you want to label any point or okay any line. You can just add the annotation here. Then if you want to display the legends, if there are multiple properties, you can display the legends. You can print the plotter image directly. Then you can copy the plotter image either in the Word file, Excel file, even in your workspace here. Okay. And then again you can export the values, only the values in the form of txt file. Okay, that is possible. Okay, again like if you want to change the values or the properties of the component, you can just double click on the product. For example, I have double click on this cylinder. So here you will find all the properties associated with that product. For example, you can see this image with some equations, then modeling parameters and characteristics, external data. You can also check the units. So you can configure the product as per your requirement. Okay, again the operating conditions. Okay, then we have the force curve. We have the driving force curve, then resistive force curve. Right. So if you have the data here, you can edit the data here. There is a builder option. If you want to make some changes in the design, like you can see the carriage, piston. Okay, so you can make the changes in the design. You can add the spring here. Okay. Similarly for the directional valve also, if you just go to technical specification, okay, you can change the command selections like if you do not want the solenoid, you can add the push button, roller, spring, okay, lever, you can add anything. Even the spools, all the types of like standard spools you will find here. Okay, okay, yeah. So this was about like the basic hydraulic circuit, and this is like on-off valve. If I want to use the proportional valve, how you can use it? So what I will do, I will add a like motor and a proportional directional valve in the same circuit. Okay, and we will see how it works. So I will just go to proportional hydraulics here, and I will take a 4-port proportional valve here, and then I will go to hydraulics, and then I will go to actuator, and here you can just take a bidirectional motor. I will take with shaft. Okay, so you can take this. Okay, and I will just connect this like motor to this proportional valve, and then I will connect this to the main circuit. Okay, now like for the proportional valve, we have to either connect it to like a joystick or a pedal. So for that, I will go to environment and control library. So here in the environment and control, you will find the PID, then set point devices like joystick, pedal. So for example, I will take a joystick here. Okay, and I will link this joystick to this proportional valve. Okay, so here the output signal for joystick will be JYX and JYY. Okay, so here I will go to proportional valve. Okay, so I will just link one left solenoid. Okay, so I will connect to JYX. Okay, and I will take one pedal also, and I will link it to motor. Okay, and here I will check the, you can click on motor and you can check the radial speed also. Okay, and when you start the simulation, right, so you can see here how it is working. You can click on this joystick, see how it is working. You can see, you can apply the pedal resistive force, and then you can see there is a variation in the RPM. Okay, so you can, oh, so you can see how it is working. Yeah, so I hope like everyone is able to see my screen. Okay, okay, okay. So if anybody has any questions, you can just post the questions in the question pen. I can see it's free or license, so it is a license software. Okay, not able to see. No, my video is properly visible to all. You can check it from your side. Okay. Okay, so this was about the proportional hydraulics. Okay, so I will stop the simulation for now. And here, um, so this was the circuit using like ISO symbol. Okay, so we can create the same circuit using the like illustrated components also. Okay, for that, uh, like you have to go to illustrated library. Here you can see the orange color symbol. Okay, and when you just click on this symbol, the library will open, and this is the illustrated library where you will find the library for aeronautics, DC electrical, residential electricity, then input output PLC cards, motor control and renewable energy. Okay, then cylinder plus load, then illustrate components for hydraulics, sectional components, which I have opened already. Then P and ID components, one line, PLC, pneumatics, section, then sectional components for pneumatics. So all these libraries will be used in the webinar series, okay, which we have organized. So today I will be using the illustrated components of like hydraulics, okay, sectional components of this. So other libraries will be used in other webinars. Okay, so we have to just draw this same circuit using the illustrated components. Okay, so I will just adjust the screen. I want to increase the page size. You can increase the page size, so there is like a Under the documentation, you can see the page setup. So you can increase the page size. Okay. So I will move this aside. Okay. Okay. So what I will do, I will take a motor. Okay, I will take bidirectional motor here. Okay. And then I will take a valve, proportional valve. Here you can go to proportional valve. Right. So I will take a 4 by 3 proportional valve here. Then I will take a pump. I will take a unidirectional pump here. Okay. And then I will take a tank. So you can take a tank here. Okay. And then a relief valve. So I will take a relief valve here. So you can rotate this. Okay. And I will connect this circuit using the curved link. Okay. And here I need a fitting. So I will take a T fitting here. Uh, Maybe I will take a four-way fitting. Okay. So this will help me. Okay. You can connect this using curved links. So here you can change the control. Okay, so you can make it to return line, then drain, load sense. You can change it. So you can just okay and connect this. Okay, and this I will connect to the tank. So this will be our return line. Okay, so this will be return, and here I will take one more cylinder. Take one cylinder and the directional valve, on off valve I will take. So this I will, yeah, here I will take the, okay, and quickly I will just connect this to the cylinder. Okay, and this should be to pump. Okay, and then I will zoom all the components. Okay, so this one is left. This also I will connect to T return. Okay, yeah. So in order to simulate this, so this I can link to the um, our JYX, that is our signal. Okay, joystick, and this one I have to link to like either PLC circuit or electrical circuit. So quickly I will draw one simple electrical circuit here. in order to drive this um, directional valve. Okay, so I have taken a 24 volt and a common, and I will take a normally open push button. Okay, so I will take a copy of this. I will take a solenoid. Okay, and a solenoid 2. So here I will take the straight line. So we will connect this. Okay, and I will zoom all the components, and we have to connect this to electrical circuit to this DCV. So we will just left like double click on this DCV. Here you can see the left solenoid and right solenoid. I will search for solenoid 1 here and link to left solenoid, and then click on right solenoid to link it to solenoid 2. Okay, so I will start the simulation. Okay, and you can use the joystick. You can see. Okay, so this I have not linked to this electrical circuit, so this also you can link it. It is very easy. You can see. So in this way you can like make ISO symbol circuit with the help of like you can make the circuit using the illustrated library. Okay. Okay, so this was about the illustrated components. Okay. Yeah, so one more thing which I wanted to show you is regarding manufacturer's catalog. So here you can also use the manufacturer specific components. Uh, for manufacturer's catalog, we have two modes. We have offline mode and online mode. So offline mode, we call it as catalog manager. Okay, we have catalog manager. So here like you can download the catalogs and like you can keep it in your system, and then you can use it without the internet. But if you have internet access, then you can directly click on online catalogs. Okay, so here the page has opened in my next screen. Okay, so I hope the online catalog is visible to all. Right? Okay, so this is the online catalogs where you will find all the updated catalogs, right? So if anybody is using Automation Studio, so you can check the Automation Studio catalogs also. So here you can go and check the catalogs. Okay, so you can check this. Okay, so here like I have taken one component of bus exhaust, that is the cylinder. Okay, so this we have created. So you can see this is the manufacturer specific behavior and this is manufacturer specific product. Here you will get one document, like students will be able to learn about this product directly from this document. Okay, so this is the link where you will find the specifications of the product. It will direct to this website, Rexroad website. Okay, and there is a test bench where you can test the product. Okay, and the image of the product you can see. Now you can just drag and drop this product directly in your workspace. Okay, so you can just take this. Okay, and I will replace this manufacturer specific product with the generic component. You can see, and when you just double click on this product, you can see all the properties. Okay, they are not editable because they are like the manufacturer specific product, right? Here you can see the operating condition. The maximum pressure is 105 bar. So here I will, during the simulation, I will make the pressure of 105. Okay, and when you just start the simulation, okay, still it is not moving. It is showing me the red color, means there is some fault. uh, Free connector. Okay, the product is not connected properly. Okay, maybe I will try to take another component here. Oh, sorry. Hmm. So you can take other component. Okay, it is not moving. There is some problem. Okay, so let me check. Okay, but you can use it in this way. So it is very simple. Like, yeah, now it is moving because the other circuit was linked to this main circuit. So now it is moving. Okay, so in this way you can just use the manufacturer's catalog. Okay, okay, okay. Okay, so that was about the manufacturer's catalog. Now moving to the virtual trainer part. Okay, so as I told you, like we have different virtual trainer kits introduced in Automation Studio. So we have virtual trainer kits for electrical, you can see, rail logic, then residential electricity, then we have robotics, which we have introduced recently. We have a separate webinar on robotics, then hydraulics. Okay, okay. Then pneumatics, you can see. Okay. So I will take a virtual trainer kit of robotics, sorry, hydraulics here. Before that, I have forgotten to show you the PLC. So I will link this circuit to the PLC now, or I will just draw a separate circuit. I will, what I will do, I will just take this copy and I will take a new diagram here. Okay, okay, and we'll delete this and Okay, so we'll link this hydraulic circuit to the PLC circuit. So we have like PLC, like different types of PLC like Allen Bradley, IC Standard, Siemens, LS Electric, and Mitsubishi. Um, so for so I will take the PLC cards here, input output card. Then I will take the ladder. Okay, so I will take a rung here. Again, I will increase the page size. Okay, so here I will take uh, 24 volt, a copy of this, take a common. Okay, I will take a push button here. So link to in 0. Similarly, I will link it to input 2. Okay, okay, then I will take a solenoid here, one for extend, and another I will take it for retract. Okay, then we will take a rung, sorry, in the rung we will add the contact, normally open contact, and then I will add one normally closed contact here, and then a output coil. Okay, so you have to just connect this. Okay, I will take a copy of this here again. Okay, yeah, right. So now we have to connect this rung ladder diagram to this PLC cards. Okay, so here I will just double click on this normal open contact, and just you can link this. So here you can see the push button is linked to in 0. So I will link it to in 0 here. So to in 2 will close, and the first output is to out 0. It's to out 0. Yeah, input 2. Okay, and it will be to out 4. Okay. Okay, so this ladder diagram is now linked to the PLC card, and then we have to link it to the hydraulic circuit. So it is the same. So you have to just double click on this directional valve, and you have to search for the variable and link it. So you can just start the simulation. Okay. So you can say how it is working. So likewise, you can connect this to like illustrated components also. So if I want to connect to this illustrated components, here I will just okay, and left solenoid I will search for extend. retract. Okay, and I will take a like a component view of this. Oh, sorry. Okay, and we'll paste it here. Okay, let me zoom the page. Okay, and we will start the simulation so you can see how it is working, right? So with the help of document view or component view, you can take a snip of that circuit from other diagram, other sheet, and you can use it in your other diagrams also. Like if you have linked your circuit to other circuit like electrical circuit, so likewise you can use it. Okay, yeah. Okay, so that was really related to PLC. Okay, and then I was showing you the trainer kit. So quickly I will just move to hydraulic trainer kit. So you can see the templates here. Like okay, so likewise you can use templates for other technologies also. So I will just show you one example of hydraulic trainer kit. So I will not save this. So the manufacturer's catalog will be updated like frequently because it is a continuous process. We keep on updating this catalogs every time, right? So with the updated version, you will get the updated catalogs. Yeah. So this is one template of hydraulic trainer kit. Okay. Here you can see the relay logic, some momentary push buttons, okay, HMI lights. So you can make the connections. For example, I can make a simple connection here. Okay. So I will connect this to. So here you can adjust the curved line. Yeah. Yeah. Here you can also change the color. You can go to edit tab and you can change the color. Right. Yeah. So you can make the connection like this. Okay. So if you want to make other connections, you can just make this. Okay. So that is wrong. This one we have to make it here, and this one I have to take it here. Okay, and then now you can make it. Okay, so in this way you can make the connections. You can create your own virtual trainer kits. Okay, so that is totally possible. So you can also make combination circuit like here we have used the relay logic and then push buttons. Then hydraulic circuit, you can make the combination circuit using like hydraulic, pneumatics, then other circuits like electrotechnical. Okay, so you can use these components from Illustrated library and you can create your own virtual trainer kit. That is possible. Okay, then again the technical training material tab. Right here you can see the like technical publications. So for example, you can see the technical publications from here. Um, Different publications, you can go here and click on the exercise. Okay, so you can see there are different exercises available for students to learn, right? Hydraulics, pneumatics, you will find it like both the technologies. So this is hydraulics only. So there are some chapters where is pneumatics also. I need to check where is, so this is pneumatics. Okay, so students, you can just learn from here. Even like these circuits are using the ISO symbol, you can try to create this same circuit using the illustrated components. Okay, and then the teacher part. So here you can, this is the like hydraulics teachware. So you can go to teachware here and you can start using the exercise. Okay, so there are different exercises. Okay, based on the subject. Like this is the physics one. If you want to see for like circuits, you can see there are different exercises. So even professors can create these exercises. Okay, okay. Yeah, so we are at the end of the webinar session. So if you have any question, you can ask now. And the last part which I wanted to show you is again the some industrial example. So this is one example of telescopic dump truck. Okay, you can see the hydraulic circuit behind the dump truck. Okay, so here this is the hydraulic circuit which is linked to the mechanism. This is the mechanism which is created using the mechanism manager in Automation Studio. This is the 2D which is again created in Automation Studio, right? Again, I will play it. Okay, so students can create these circuits. Okay, so these files, some of these files are available in like our website also. So if anybody is using Automation Studio, they can go to open project here, and here you can click on demo projects, right? So from here you can just like take that projects and learn it. Likewise, I have already opened one project. Maybe I will just check. Um, yeah, I will try to open this file. Yeah, continue. Okay, so again, this is one example of PLC which is linked to pneumatics. Okay, so I will adjust the components here. Okay, yeah. So here I have started. Oh, so I have to switch it on. So you can see. So this is the Siemens PLC. There is Siemens Sematic S7 1200. Okay, which is available in illustrated library, right? So you can take this PLC. Right. So this looks exactly like which you might be using in like it in labs, your automation lab or mechatronics lab. Yeah. Okay. Yeah. Okay. So that is all from my side. So if you have any question, please let me know. Right. So today's webinar was on hydraulics, electrohydraulics. So there is again the next webinar which is on pneumatics, which is on 16, that is Thursday. And we have, as I told you, like this is a series of webinar. Please do register for other webinars also. Right. If anybody has not received the invitation for these webinars, like please let us know in the chat box. We will send the invitation to you all. Yeah. And if you want to arrange personalized demo, if you want the quotation, want to understand the price, please email me. Okay, this is my email ID. You can email me. Okay. I hope you liked today's session. Right. So if you have any feedback, also you can just email me, or you want to understand any specific thing or any you have any query, technical query, also you can reach me. So yeah, so regarding some questions, I will see which questions I can answer here. Um, so regarding the licensing and cost, we will get back to you. So recording you will recording and certificates you will receive by tomorrow. Okay, so yeah, we will note it down those who have not received the invitation. Okay, so we will send this. Yeah. Okay, so my colleague has noted down who all not received the invitation. So we will email you. Okay. Yeah, you will receive the certificate by tomorrow. Yeah. Okay then. So thank you very much for attending today's webinar. Thank you. Have a good day.